There's a star that lights the road. I take this ride. Just drive. I wanna be the only one to make it to the light. I take it to the edge where I live 1,000 lives. But maybe I could be the one. Right into the setting sun tonight. Just drive.
Hello and welcome to day 2 from Jerez and to the notebook. You find us inside the very bijou surroundings of the Renault Sport F1 motorhome. So we're going to talk the new engines with Remy Taffin, who's sort of in charge of everything Renault engine-wise at the track. I think that's fair to say?
Yes, it is.
Okay, thank you very much for joining us. Now, here we have all the bits. I'm just going to get my pen out. We're going to talk about what all the bits do, the engine itself, the KERS, what's now called motor generator unit MGU-K, the KERS that we're used to that I spoke about yesterday, the new KERS, the secondary KERS, which is attached to the turbo. We'll talk about that and the turbo as well, and the battery, which is now called energy store, and then we'll talk about how it all goes together. So let's go through it if we can. First of all, the engine, Remy, maximum 15,000 RPM.
Yes.
So that's a cut from last year when it was 18,000. What's been the biggest thing with designing this new sort of tiny engine? Is it making it reliable? Because they've got a rate last 5, you can have only 5 per driver per season now.
I think the basic of the engine itself is not that difficult. I mean, we've gone from the V8 to the V6, but the real thing is obviously we downsized the engine, so now it's 1.6 liter, and the main thing is turbocharging and direct injection. So let's say that the main parts, crankshaft or pistons, have to be a bit more strong than what we have at the V8 due to the nature of the turbocharging and the pressure we get in internally. But there's not, let's say, a big deal. It's something that we know and we can normally sort out well. Okay,
because the pressure inside the combustion engine is twice as much as the V8, is that right?
Yes, and you basically quoted the revs. Obviously we got the revs down by a third or nearly 50%. If you look at 10,500 would be the maximum torque. So obviously there is much more torque if we want to deliver this power, which is going to be very close with the two motors to what we had before.
Okay, so even though the capacity has gone down, you're still with all the, because I think it's quoted about 600 bhp for that, but
yes.
Then add in the power that all the you get from the energy recovery system.
We're going to get
approaching the same
160 from the K,
160
so
horsepower, yeah.
Total will be 760, 770.
Okay.
Whereas last year we had something like 750, 760 from the internal and another 80 from the K, sorry.
Okay.
So
something I didn't know is that it says here in your bump, and excuse me, I've got the bump in front of me, the pressure generated by the turbocharger may produce a knocking within the combustion chamber that's very difficult to control or predict. Should this destructive phenomenon occur, the engine will be destroyed immediately.
yeah, I think
Have you had any signs of that happening so far, or is it just
not on track? But obviously on the dyno, when we have experimented the first engines and we do testing, yes, we had sort of this thing. And I can quote an example where we had this phenomena after 5 or 6 seconds running. Everything was rinned piston wise, so we had to be very careful. But obviously we put a strategy in place in this where we look after knock and we apply some variation on the parameters that control the combustion, so that we make sure we don't get into the situation.
Okay. The engine itself, I've seen it installed in a couple of cars. It's quite small. Have you actually had to build some, of course it's small, it's a 1.6, builds a frame around it?
Yeah, it's basically some casing we have to fit in to try to get the gearbox onto it. And maybe also the other thing is the fixing points, because obviously we have to get onto the gearbox, and either in length or in width we have to compensate compared to the V8. So we have obviously to get into some let's say, spacer or different casing.
Yeah, okay, some little spacer in there. You mentioned direct injection. Of course, previously the fuel was mixed with air in the combustion chamber, much like the normal internal combustion engine. Now it's direct injection, much like many road cars.
Yes.
That's to save for fuel efficiency,
Yeah,
and does it produce any consequences?
I think the main priority was to get fuel efficiency. You know that was something like down 35% compared to V8. So first we do turbocharge, which is downsizing, and it normally goes with a direct injection to try to get the most out of the combustion and obviously from the fuel. And so it's something we've experienced. And we are much higher pressure than what we had last year, and this is going to be helping us to save fuel or to be more efficient.
Okay. Something also interestingly that you will still be able to cut some cylinders on the engine for better drivability, just like last year when you could run it on 4 instead of 8 cylinders.
Yeah, definitively we can. We could either run on 1, 2, 3, 4, 5, 6 cylinder because. Now we've got software on our horn, so we can basically deliver the torque the way we wish, and it's something we will be obviously doing. And the real thing is, as you quoted, we cut the injection. So now we've got the direct injection. Is very different to last year where we were cutting ignition, so we were wasting fuel. Whereas this year, if we don't want the torque, we don't put the fuel.
Okay, I understand. All right, let's move on to the turbocharger. Quite a big racing turbo?
Yes, it is, and it's actually maybe a bit different to any other application we could have seen on the racing car. And the main thing is obviously we maybe discuss it a bit further, but it's the H which is connected to the turbo, and the fact that we want to recover as much energy from the exhaust gases. So it can be a bit different to what you would have thought if you have only the V6 on its own. But since we are running an H on this turbo, we can play around the dimension and of the turbo.
Talk about the H. What we're talking about is the MGU-H. So that's what I refer to as the HERS, the heat or the TERS, Turbo Energy Recovery System. It's effectively the second one. That's the original KERS that we know about from last year.
Yes.
And then the second energy recovery system, which is new for this year, right in there, putting a turbine right in the middle of the turbo and actually spinning it up. Amazing RPMs. You're getting 125,000 RPM.
This is the maximum we can get, and that's maybe a bit below we're going to be raving. And the real fact is this is going to be the thing that is going to help us to again increase the efficiency of our engine due to the fact that we get much more energy out of the exhaust. Not only we can boost the pressure at the inlet, but also we can recover the remaining wasted energy that you normally go through the wastegate.
Okay, there still is going to be a wastegate, isn't there?
Yeah, definitively, but much more for safety in case we had the H going down.
A failure of this motor generator unit, so the extra exhaust gas has to go somewhere.
Exactly.
Okay. So are we going to see, lots of people asking if we're going to see big flames coming out of the back of cars like turbos in the old days?
It's not likely to happen due to the fact that we're not going to tend to burn fuel into the exhaust, the tailpipe, just for fuel efficiency, and we've got obviously different things to get on with the turbo.
Okay, let's move to the motor generator unit K. So this is what we referred to as KERS last year, Kinetic Energy Recovery System. It's much bigger and beefier than last year because it's got to do what, twice as much work?
Exactly. Or
10 times as much work.
Twice as much power, but something like 10 times
as much
the work. The total time compared to last year.
And it produces 120 kilowatts. Now that's 2,000 60-watt light bulbs, to give you an idea. Is that right?
160 horsepower.
160 horsepower, 120 kilowatts. I've worked out is 2,000 61-watt light bulbs all being on at the same time. Anyway, just trying to liken it to something that people might have at home. Okay. And 4 megajoules, the amount of megajoules is a measure of energy.
Yes, exactly.
So that's apparently equivalent to 8 kettles boiling at the same time.
Okay. Fine.
All right.
I did not translate it like this.
Okay, well, it's just to give you an idea of how much sort of grunt, electrical grunt that is. Sorry, I'm a bit hot this way. I've been out in the sun. It's been a very nice day here at Red. Started rainy, but it's been caught the sun a bit today. So, is there anything in particular about this one? If you have a KERS failure, it used to cost you in the race 0.3 of a second. Now it will be more than a second.
Yeah, it's going to be. We quoted 10 times the total time we're using it. So if you do a very straightforward translation, it's going to be seconds, so maybe 2 or 3 seconds, maybe more. So it's going to be hurting a lot, and also braking is going to be dealing automatically compared to last year. You could remember last year when we were losing KERS, we had sort of a message to the driver, 10 clicks forwards or whatever.
Yeah.
And this year will be automatically driven. But obviously it's going to be a bit different.
Okay, and then there's the motor generator unit H. So a lot of people, you're going to hear people call it the MGU-H. Remy's already been referring to the H, which might be just its nickname. It's the energy recovery system that runs off the turbo. Now, this looks like it's buried right in the V of the engine, which of course it is. Isn't that going to get really hot and vulnerable in there, because the incredible temperatures in the turbo, up to sort of 900,000 degrees C?
Yeah, I think the baseline behind this is the basic story behind this is obviously it's going to be hot, but you have to imagine the compressor is in this side, and then you've got the turbine here.
Ah, the turbine through there.
Okay, so actually putting the H in here is going to give us maybe a bit more easy time for it.
Okay.
Rather than being this side.
So when it's acting as a motor, it spins up the gases in the turbo to hopefully eliminate turbo lag. Is it working? Is it eliminating turbo lag, or are you still getting a bit of turbo lag? Because am I wrong? Without that, you'd have like 5 or 7 seconds of turbo lag. If you didn't have that to spin the gases up with these big turbos,
we could have a few
it would be like, oh, you're sitting there, nothing happening.
Yeah, definitively. So yes, that's what we try to tend, eliminating the turbo lag. We're not there yet, but it's definitively not seconds. We're now down to less than a second for sure.
Okay.
And yes, we try to. The objective is to try to make it as much drivable as was the V8, basically.
But is the driver still going to be able to? Is he going to have to rev in the middle of a corner, say, for example, or
let's put it this
try
way.
and eliminate turbo lag some other way?
Theoretically, it should not.
Okay.
So he will have to do a bit of a job into the corner.
Yeah.
Up until us engineers will have sorted this out. Okay.
All right. Good. We'll see who does a good job. Is there anything we need to say about this? Because the MGU-H produces AC. But then we've been talking about the battery, and the energy in the battery is DC, of course. It's a DC voltage. It's quite high voltage, isn't it? So you've got to convert it. It's quite complicated.
Yeah, if we want to make it simple, obviously both of our MGUs are AC, so producing AC voltage. Then we've got a converter within the energy store that is producing direct current that we can actually store. And then if we want to use it back again, we have to go the other way, so transform it again into AC. So we've got some boxes we can see here that are here to do this this job.
Mm-hmm. Okay, good. Let's talk about the battery then. Why has it got this very engineering sort of name like energy store? Why don't you just call it a battery? Is it a lithium-ion battery, just a massive 20 kilo battery?
I think it's also because it's how it is referred into the regulation first.
Okay, all right.
So to try to have the same naming, we use energy store, but it's really fair to say that we still use battery quite often.
Okay, and it's much bigger and a very big power to weight ratio because it's 120 kilowatts, as we said, but it's only 20 kilos, and that's pretty impressive.
Yeah,
isn't
exactly. It? That's the real challenge with this kind of battery, where it's very high technology, to be fair, and it's was very difficult to get on top of it. But
Yeah.
since you get on top of it, you get this sort of ratio.
Okay, Adrian Newey was talking, the Chief Technical Officer at Red Bull was talking about what happens if it gets knocked or damaged and then has a what he called thermal runaway, if there's overheats.
Yeah.
We've seen lithium-ion batteries, problems with these in other technologies, aircraft for example. Has that been an issue? Do you expect it? Adrian Newey said if that happens you'll have to put it in the pit lane and let it burn. Is that a concern?
No, because as far as we're as we're aware, we've got everything in place so that it does not happen.
Okay.
But obviously, if it happens, we have to get a procedure to apply, and maybe the latest would be to leave it onto the pit lane. But we have a few tweaks before we get onto this final procedure.
Good. All right. I'm sure you do. We haven't got much time, and I know you've got to go as well. So let's just talk finally then about how it's going to work on a lap. And if I just try and scroll down, then we can see where it's going to go. No, I can't do that.
Should I help you?
Yeah, go on, you help me.
I will try.
While I describe, hopefully in simple terms, I've got a few little props that I've managed to get from Jerez. It's this one here, Remy, the one where it says how it all fits together. There you go, that's the one. So if we can understand, I've got a few props here. So if that's the engine, there you go, you can see it's a 1, 2, 3, 4, 5, 6 engine there. We got a battery here, MGU-K, we'll call it there, the KERS. It's actually a little, I think it's a nasal hair razor, but anyway. And this, if we call it the MGU that's spinning up in the turbo, so I guess that would be around there. So obviously the idea is for this all to work in harmony and for the driver not to notice any difference
Yep.
when he's going. But if we have a look on acceleration, if we just scroll down just a little bit, what is working? What's gathering data? What's gathering electricity and what's delivering electricity?
Okay, if I can do it this way, I would prefer to start from braking.
Okay,
maybe.
let's start with braking. Yeah, it's this one here.
Yeah, braking, basically, driver is decelerating, so applying some brakes, and what we do is we take as much as possible from the braking into the battery through the K. So
Right.
we're spinning the K in terms of trying to recover the energy
Yep.
as it is here. So
Yep.
we replenish the battery.
So effectively the MGU-K is running up.
Yeah.
It's generating energy off the crankshaft of the engine and charging the battery.
Yes.
Okay, all right. So then on
We go.
exit braking you
Yeah.
want to do, but the MGU-H is not doing anything at that point.
If anything, not dramatically.
Okay.
If we can, the only thing we're doing at that point, just so you know, we're just trying to keep turbo in speed. So maybe we spin a little bit of the H at that point.
Okay.
Then we come on to exit of braking zone, where we go on acceleration. We've got the.
So that's on acceleration, third gear, about
it's
just
really
under.
when we go on throttle.
On
When
the
we-
throttle, yeah.
we go on throttle. What we need is we need to get the boost pressure right
Yeah.
down here.
Yeah.
So what we do, as you quoted before, we spin the turbo thanks to the H, so we can get the turbo into speed and get the right boost. So when the driver goes on throttle, he's got the right torque delivery.
Okay, so the battery is discharging then. Battery is discharging straight to the MGU-H, which is going into the turbo. It's
Yes.
spinning up the turbo.
Yes.
And the engine is still working.
Yeah, so that we can get the IC with the right boost pressure.
Right.
And then we've got actually no lag.
Okay,
As we
okay, because
discussed
that's
before.
spinning up the turbo.
Exactly.
Okay, all right, I understand. Okay, let's move down. What's the next one?
So next
you
one
want
is
to do?
acceleration.
Acceleration.
Which is this one.
Okay, so that's in the middle of. Can you just go down a touch so we can see what's happening? You're in the middle. Say this is just of course a map of Barcelona, and we're in the middle of a straight.
Yeah.
So everything is going full song. We're in eighth gear, of course, 8 gears now.
Yeah, it's going to be very similar through the straight. We say we got out of the corner. Turbo is now spinning at the right speed.
Yeah.
We've got the pressure. So now we've got the K, which is delivering power into the car. So we're
Right.
propelling the car.
So it's getting extra. The engine is getting because fuel is limited. You've only got 100 kilos
Yes.
of fuel, so you have to rely on these energy recovery systems to help, because really then you're not going to get anything. It's all right, Pete. You don't have to get too close to it. You're not going to get all the acceleration. You can't use the fuel.
Yeah, definitively. So
because you need to use this one running up.
So how to do this? We achieve the maximum power through the K with energy coming from the battery.
Yeah.
For some ratio, and we also get some energy from the H straight onto the K.
Okay.
Because when we are full throttle now, we are in excess of energy into the exhaust gases. So where on a normal application you would have the wastegate open, we keep it closed and we get the energy to the H from the exhaust gases, and it goes straight onto the K.
Okay, so this is running up. This is being run up by the turbo.
Yes.
And is acting as a generator.
Yes.
And is delivering its electricity straight into this one.
Yes.
Bypassing the battery.
It's more or less bypassing. It has to go into it, but just because it's the way we achieve it. But you could imagine it's just bypassing, yes.
But the battery can be charged and discharged at the same time. That's what I'm amazed at.
Yeah, but it's because our configuration is we've got bits into the battery.
Okay.
So. All
right. Okay, and just finally, Remy, we've managed to turn all these off. This wouldn't turn off for a moment, so I just had to stop there while I was going to get going again. Just tell us about today. Thank you so much for explaining how it's all going to be used. Tell us about today. It's been a troubled day for Renault. What have been the issues?
The main issue we've been facing is locating into the energy, so we can still see on the picture.
Yep.
And we had to fix it. We basically have I've got a part to fix it, but it's quite a time-consuming task, which we decided to achieve in the most proper way, and that's why we had to stop running at some point to fix this, but obviously stop us from running today as we would have expected. But the main aim is to get everything ready for tomorrow morning and have a very good last 2 days. So
that's been a problem common to all the Renault teams?
It's in a way a common problem, but okay. we still to see it as a different application in each car. So there is some common problem, but also specific problem to each car. The one we're going to be fixing obviously is going to be the same fix for everyone. Okay,
Remy, thank you very much. We're going to de-rig all of this, take all our clip microphones off, and we'll see you downstairs for a roundup of everybody else's day 2 at Jerez. Right, we've managed to take off all our microphones, and I put all my little props and toys in a bag in here, and timed this particularly well because Valtteri Bottas has just come out. We've got lovely backlit by the sun setting in Jerez. And does it set on a good day for you?
I think we can't be completely happy because not many laps in the end, but at least positive thing is we got much more than many other teams. Yeah. And
you did quite a few laps for the modern F1, for this weird 2014 F1 actually. It looks like you did a whole Grand Prix.
Yeah, it seems like, yeah, but I mean, it's good that we got some good running with Inter tires and some good running with dry tires, and really it's just, picking up the picking up the points and problems and fixing those and keep improving all the time. I mean, we are learning so much all the time. Every time we go out, we come back. We are always more wiser than the time before.
Okay. One last question, because I know you've got to go and talk to the written press who are in there. Sorry about my carry bag. We've just been talking about engines. Is it sort of seamless at the moment, or are you still feeling weird sensations when the ERS-K is sort of braking the car for you, and when the ERS-H is spinning up the turbo, stuff like that?
Everything is working quite well already. I mean, it's only day 2 and it's running quite smoothly, but we're definitely improving that all the time. The drivability is getting better, and there's a lot of things we are getting better and better all the time, and we just need to keep doing that step by step, and then hopefully we'll be ready for Melbourne.
Okay, thanks a lot. I bet it's weird, the difference.
Sorry?
I bet it's weird, the difference. I bet it feels weird.
Yeah, you get used to it quickly, but I really like the torque. It's nice.
Oh, fantastic. Yes, that's the torque. Thank you, Sophie. Yeah, that's the torque, actually. That's another thing we didn't talk about. Torque, get it? And that is 3 times the torque that they've got. And he's enjoying the torque, but then you've got the problem of the torque and cold tyres and hard tyres, actually, as well. So they're finding that you put your foot down, the tyres are much harder, and then the back is sliding around. But Valtteri's saying in this particularly Finnish way that he's enjoying the torque. Right, I think that all the people who wanted to get in the back of our shot have actually got in the back of our shot. So there you go. So bets finished. So well done to them. Yeah, happy? Good. Excellent. All right, good. So let's go through everybody else. There's just a couple of things on the fuel as we try not to get run over by the Marussia truck, which has just delivered all the extra bits and pieces that they've needed. I'll tell you about Marussia right now, actually. Their car arrived about lunchtime in a small trailer run by a Ford transit van. If you ever pass one of these F1 trucks on the road and think, oh look, there it is, it's got a Formula One car in the back. The likelihood is that it doesn't, because the teams tend to deliver the cars around Europe in the back on little trailers with sort of aerodynamically sculpted trailers, trailer covers attached to a transit van, or sorry, other vans with good capacity are available, because they're not subject to all the speed limits that those big trucks are, and they have 2 drivers, so they can take it in shifts. They don't have to stop like some other HGV drivers would have to. So it's a nice little thing that they do to actually get the cars to the circuit as quickly as possible. Just a little thing you might not have been aware of. So that was the Marussia. It is here, and it is running tomorrow with Jules Bianchi. I'm not quite sure when Max Chilton is going to run in that Marussia, but Marussia also saying yesterday they're very happy with Ferrari. They've really been nicely surprised about the cooperation and collaboration that they've had with Ferrari, and that's good. 10 Ferrari people they've had their factory in the UK sorting out all the installation while they get their car sorted. So as that Marussia support truck leaves the paddock, I can tell you what I was going to tell you about the fuel. Firstly, hope you understand what we were talking about. I know it's quite complicated, and don't worry, we will be explaining it much more in future notebooks, and indeed in our race and qualifying programs and preview programs, the F1 show before the season. So we're going to go into it much deeper and more extensively. But effectively, what is impressive is that all the energy recovery systems and all the motor generator units are working together in unison to save fuel, so that you're not going to be able to run the engine just completely full on for the whole Grand Prix, because you'll run out of fuel. So you need to be generating electricity all the time, charging the battery, then discharging it, then using the MGU-K and the MGU-H in unison together with the engine to save fuel. The other thing about 100 kilos for the whole race, it's not actually, it's 100 kilos of fuel from lights out to checkered flag. A lot of people don't realize this. So when they go out for the race, they will actually have probably 110, 112, 115 maybe kilos of fuel in, because of course they'll have to do the lap to the grid, and then they have to be guaranteed of doing the in lap as well. And there's a spy in the cab, if you like. There's an FIA fuel flow meter, which is going to act as a kind of governing spy, if you like, in the car. And that's going to be connected to telemetry. So that's how the teams are going to be able to tell live in real time on the pit wall whether they're using too much fuel and whether they have to tell the driver to back off. Because they'll be getting a message from that fuel flow meter that you're using too much fuel and you're not going to make the race, the end of the race, using that 100 kilos of fuel. Of course, they're unlikely to run out of fuel because they'll still have extra fuel in there, you see what I mean, to do the in-lap. It's just that then, if they go to the end of the race and that fuel flow meter tells tales on them to the FIA and says, look, he used more, 101 kilos, 102 kilos, then of course they'll be disqualified, or some horrendous thing will happen. But just a measure of how much in demand Renault are. Look at this scrum at the back. Oh, it's just the end of it, at the back of this truck where we just did there you go, Pete. Nice, quick on your feet. The interview, and a lot of people wanting to know why they had the problems they did that Remy has just described to us. Right, we're still going on far too long, so I know I'm giving my schedulers heart attacks, so I'm sorry about that. But let's just go quickly through everybody else. Toro Rosso, terrible day for them. Danny Kvyat did no laps at all, so they're going to sort out why with Renault that was, and whether they can actually get going tomorrow. They seemed, as you heard just then, to be quietly confident of that. Force India, Sergio Perez did 37 odd laps, stopped out on the track with some smoke and overheating issue for him. So overheating not limited to the Renault engined cars, and so they had a bit of a problem that stopped Force India's progress. Esteban Gutierrez, as we are near Sauber, or rather there's a bloke in a beanie hat from Sauber, did 51 laps but was slow, and there was a good reason for that. They found some system problems. I think he was about 8 or 9 or 10 seconds off the pace. They found some system problems which meant that he couldn't push, and then he had to go around slowly and sort out those system problems. So that's why Gutierrez was slow. It's the end of his test now. Adrian Sutil takes over from Esteban Gutierrez for the last 2 days of the test. We've spoken about Marussia, we've spoken about Williams. Should we talk about Force? We've talked about Force India. Where are we next? Mercedes, as Graham Loudon comes sauntering towards us in his very cool way. We've already spoken about Marussia. Going to be running tomorrow?
Yep, hopefully, yeah. Good. So cars arrived, so getting it all ready now.
Are you going to elaborate on exactly what this tiny little problem was that meant you missed the first start of the test? Don't feel under any pressure. But
no.
I set myself up for that one.
But you know, the car was pretty much complete. But as you know, you got to go through a whole lot of checks and everything on all the various systems and everything. And it was clear there was going to be a gremlin, and it was easier to sort it out back at the factory than to bring it down here and do it.
So it wasn't a massive thing, it was a small annoying thing.
Exactly, yeah. If you looked at the car before and after it, everything would appear absolutely identical. Right. So it was just one of those things. But it did make sense to do it there rather than come down and and do it down here. So
paid a heavy price though?
Well, it's not as if everyone's been pounding around while we've been absent. So, the main thing for us now is try and if we can get a good start tomorrow and touch wood, be reliable out the box, then we'll make up the lost time quite quick. Okay. And it's so important to just get some mileage on the cars. So
it is. And Mercedes did that very well. Sorry, I'm just doing a seamless link. Yes. Yeah, thank you very much. Sorry, I'm running out of time. Mercedes did that very well. The mileage was unbelievable today. Really, you've got to say this is Mercedes. This was Mercedes' day. They were doing a lot of aero running, aero paint, aero Flovis paint on the rear wing and the rear wing end plates of their car towards the end of the day. Rosberg did nearly 100 laps, 97 laps, amazing. They really got the day they wanted after the front wing failure yesterday. They sorted the front wing failure out. They've shipped a new one in from Brackley overnight, so that worked very well. But it did add weight. And Paddy Lowe, the team boss, Brackets Technical, pretty much admitted in his briefing to us yesterday that the car is a little overweight at the moment. So the Mercedes car is overweight. We don't know if everybody else is overweight. We imagine they pretty much are. Everyone kind of admitting that you're actually going to start Melbourne. They're going to try and start Melbourne on a significant weight loss program. I know what they mean, Pete. Ha, boom, boom. Right, sorry. Let's talk about Ferrari quickly. Reasonably happy with what they did. I think you probably would have seen James Allison in the program before us talking about Kimi Räikkönen and his soft hands. Was it soft hands, Pete? Is that the way he described it? Kimi's soft hands, and how he's so sensitive to feedback and what the car's doing. That's been so valuable to the engineers. So the numbers seem to correlate with the wind tunnel, which is absolutely crucial. Hasn't always been the way for Ferrari, so that's great for them. And the cooling is okay. Not a bad start for Ferrari, so well done to them. McLaren, I haven't really got time to discuss the Boulier thing, really. So Eric Boulier, racing director of McLaren. Wow. Okay, Eric Boulier. He's not very McLaren. I mean, I've got nothing against Eric Boulier, don't get me wrong, but I can think of about 1,000 people in this paddock who are more McLaren than Eric Boulier. First European in fact, anything other than English-speaking sort of team boss they've had, and they still don't have a team boss. I mean, clearly Ron Dennis is going to be in charge. Martin Whitmarsh, it seems, has been unceremoniously out of there, dumped, and potentially could end up as team boss of Lotus. You never know. As I said before in one of these things, seemingly there are many teams in this paddock who would give him a job. These two chaps have been on this about 10 times now. They asked me earlier whether they can get in the back of shot, so indeed they have. That's Craig Slater with just outside Jenson Button's motorhome in the background. Yeah, so McLaren, they've got some great wishbones, which we will talk about in Development Corner either tomorrow or... you're getting broody, Pete. Either tomorrow or on the final days. Nice, really touching tribute that Jenson is running. We managed to see him to his dad, little Papa Smurf in a nice sort of cartoon way. On his helmet to John. It's really, really sweet. Yeah, we're talking about Billy Edwards. I'm sure we'll talk about that more. And just finally on Marcus Ericsson, they have more Renault problems at Caterham, but they think they'll get a little bit sorted tomorrow. Only did 11 laps, and Marcus Ericsson finished 13 seconds off Jenson Button's fastest time of the day. Right, we've got to go. Bye-bye.